Hi, and welcome to Jeopardy! AP Calculus Edition. I'm your host, Emma. Let's meet our contestants.
Oh, salutations, fellow peers. I am Nathan Portolano. As a top student in America, I intend to dominate and destroy the average competition. I am a 9th grader and have taken 12 AP classes. I try to expand my horizons by taking challenging classes and pushing my brain to its full capacity. I've won the National Spelling Bee for 5 years in a row, so I know I'm the best. I've been called to the National Math Board Council, which is such an honor, and I completely deserve it. Fun fact, the actual percentage of my likelihood to win calculated by the indirect variation of the integral to the average IQ of the fellow competitors, or in other words, 100%.
So, I'm Tess. I'm kind of a big deal. You probably saw me playing in the Water Polo National Championship last weekend. I won the MVP, of course. I took AP Calc because Montana Tech University, which I got a full-ride water polo scholarship to, is requiring me that I take this class, but I really couldn't care less about it. I like to fill my time with water polo, lifting, swimming, more lifting, carbs, cardio, and winning everything. So, yeah, can't wait to add this competition to my collection.
OMG, hi! My name is Mac, and I'm so excited to be here. My hobbies include makeup, fashion, hair, and cuticle care. I have a teacup chihuahua named Coco, and I absolutely adore stalking Instagram models and celebrities in my free time. I took AP Calculus because I knew there would be so many cute boys in my class.
Hey, my mom forced me to take calculus, which is stupid because I don't need to be a drummer. I'm into darkness, heavy metal, and death. Yeah, that's it.
No matter what you say, you find it happens all the time. Love will never do what you want. I'm living in the 21st century.
You guys know how this works, so let's get started. Nathan, since you arrived first, why don't you pick our first category?
Graph geometry. Let's pick that one. That's my favorite.
You are such a nerd. Oh my gosh.
Let f be a function defined on the closed interval x is greater than or equal to -3 and less than or equal to 3, with f of 0 equals 3. The graph f prime, the derivative of f, is shown below. The interval of 0 to 2 consists of a semicircle. Find f of -3 and f of 3.
What is f of -3 is equal to 5 over 2? And what is f of 3 is equal to pi plus 9 over 2?
To find f of -3, you first must establish a relationship. F of 0 minus f of -3 is equal to the integral of -3 to 0 of f prime of t dt. After finding the integral of f prime of t, isolate f of -3 by subtracting 3 from both sides. Doing so should yield f of -3 equals 5 over 2. To find f of 3, you must also establish a relationship. F of -3 minus f of 0 is equal to the integral of 0 to 3 of f prime of t dt. After finding the integral of f prime of t, isolate f of 3 by adding 3 to both sides. Doing so should yield pi plus 9 over 2.
And that is correct!
Yes, my knowledge is impeccable. I'll go with the elements of a vampire next because vampires are pretty cool.
A vampire 6 feet tall walks at a rate of 5 feet per second towards a streetlight that is 16 feet above the ground. At what rate is the tip of his shadow moving? At what rate is the length of his shadow changing when he is 10 feet from the base of the light pole?
I got a what is -3 feet per second? tip of the shadow is moving. And then for part B, I got what is -8 feet per second. Length of the shadow is changing.
We know the height of the lamppost, L equals 16, the height of the vampire, V equals 6, the rate at which the man walks toward the streetlight, dx over dt equals -5, and the length of the man's shadow from the base of the lamppost, x equals 10. Since the man is walking towards the lamppost, by convention, the rate is negative. Using similar triangles, we can see that the ratio of L to V equals the ratio of x to x plus y. We simplify our proportions and differentiate to determine the rates of change. That's the definition of a derivative. To differentiate, we use the product rule and the chain rule. We plug in the numbers to obtain dy over dt. The answer is -3 feet per second. To solve for ds over dt, you must set s equal to x plus y, then take the derivative of both sides of the equation. Then plug in the values you know for dx over dt equals -5 and dy over dt equals -3. Then ds over dt is equal to -8. The answer is -8 feet per second.
And that is correct!
Let's do makeup math, because I like eyeliner.
Molly has a cylindrical tube of lipstick. The volume of a cylinder is pi r squared h. The height decreases as she uses the lipstick at a rate of dh over dt equals -0.9 centimeters per day. The initial height is 12 centimeters and radius is 3 centimeters. How much lipstick does she have left after 10 days?
What is 27 pi centimeters squared?
The volume of a cylinder is pi r squared h, and dh over dt is equal to -0.9 centimeters per day, and the initial height is 12 centimeters, and the radius is 3 centimeters. The height at day 10 is h of 10 equals 12, plus the integral from 0 to 10 of dh over dt, because 12 is the initial height, and the integral is the change in height from 0 to 10. So the equation is h of 10 equals 12 plus the integral from 0 to 10 of -0.9 dt. The integral equals -9, so you plug that into the equation and it is 12 minus 9. Your final height is 3. You then plug that into the volume equation. That makes it v equals pi times the radius squared, which is 3, times 3, which is the final height. And your answer is 27 pi square centimeters, which is the final volume.
And that is correct!
Let's do polar position, because that means ponies, right?
For time t is greater than 0 and less than 8, a water polo ball travels through the air. The velocity of the ball at time t is represented by the equation v of t equals t squared plus 3t plus 1. The ball is at position x equals 5 at time t equals 0. Find the acceleration of the ball at t equals 4. Is the ball speeding up or slowing down at this time? Explain your reasoning. Find the position of the particle at time t equals 4.
For part A, I said what is A at time t equals 4 is equal to 11, and the ball is speeding up at time t equals 4 because both A of t and B of t are positive. And for part B, I said position at time t equals 4 is 163 over 3.
Acceleration is equal to the derivative of velocity. Therefore, acceleration is equal to 2t plus 3. For the acceleration at time t equals 4, plug in 4. The acceleration at time t equals 4 is 11. The second part of the question asks if the ball is speeding up or slowing down at time t equals 4. The ball is speeding up when both acceleration and velocity have the same sign. Velocity at time t equals 4 is equal to 29. Since both the acceleration and velocity at time t equals 4 are both positive, the ball is speeding up. Keep in mind that the problem told us the initial position was x equals 5. Position at time t equals 4 is equal to the initial position plus the integral of velocity from time t equals 0 to time t equals 4. Plug in 4 to the equation of 5 plus the antiderivative of velocity. The position at time t equals 4 is equal to 163 over 3.
And that is correct!
I guess I have to choose, even though I'm going last. I guess we can go with difficult differentials.
Find the differentiable equation x e to the x squared dx plus y cubed minus 1 dy equals 0 for when y of 0 equals 2.
Yes! What is 2e to the x squared plus y fourth minus 4y is equal to 10?
First, isolate the y's and the x's. Then distribute the dy to y cubed at -1. Then integrate both sides. Use u du substitution to integrate x e to the x squared dx. Once integrating both sides, isolate c to find its value. After that, plug in c to the equation to get your final answer. The answer is 2e to the x squared plus y to the fourth minus 4y equals 10.
And that is correct! 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 Congratulations, winner. Let's go take a look at your prize.
Yay! Is this like a helmet, perhaps?
Oh wait, there's more!
Oh my god, it's a brand new car! Yay, I got a new car. I don't have to have my mom drive me around anymore. Oh, wait, sorry. Oh, shoot, sorry. I hitting the pen. How does this work? Bye.
And that's all for this week. Catch us next week for a special edition with AP Environmental Science.
So, I'm Tess. I'm kind of a big deal. You probably saw me playing in the water polo champion.
And then Tess is over here jiggling.
Oh,